Alright, guys, we'll do bubble sort today, and there was a reason I had kept both of these different topics together because a 2D array used a concept of a loop inside a loop, which is also called nesting. All right, nesting says we have this loop inside this loop. The outer loop defines, or it works like this way. Outer loop defines that how many number of times the inner loop has to run. The inner loop runs for 5 times, and 5 times of this 5 times, it says that the overall algorithm will run for 25 number of times. Fine, we're going to use the same concept of nesting in the bubble sort concept, and here we have the bubble sort. I've set up some things already, and we'll start with, as the name suggests, bubble sort. Bubble sort means lighter values bubble at the top. That means bubble sort is an ascending order sort. And ascending order means we start with smaller values and move up to the bigger values. Okay. Here, I've taken the worst case scenario, and there are also best case and average case scenario. Worst case means that if we have to sort it alphabetically, the values I've taken as test data are already in the exact descending order. Okay, so every value has to be shifted. We can assume it in the horizontal way as depicted in here, and the same depicted in here as the vertical. Okay, the lighter values are at the top, and when they are laid down as from left to right, it is 1 2 3 4 5. Okay, our goal is to sort the unsorted array, which is the worst case 5 4 3 2 1, into the sorted array 1 2 3 4 5. And before going on, I'm using the same name as used previously. The name of the array is my array, and the length of array is 5. All right, we'll start with there is an important concept of swap. The algorithm says compare two adjacent values, and if first or left value is greater than the second or the right value, swap them. All right. It then says move to compare second and third, and then third and fourth, and so on till the last value, and keep on swapping according to the rule. And rule is if the first value or the left value is greater than the right value, just swap them. Okay. And then it says keep on performing the same process until all the values are sorted. We'll start by comparing 5 and 4, the first two adjacent values, and as the rule says, if left value is greater than the value on the right, swap them. So it will be 4 and 5, and rest of the values will be unchanged because we haven't looked at them. Okay, then he says move to the second and third value, compare both of them, and then check according to the rule. 4 already done, and we have 5 and 4, 5 and 3 to be compared with. Okay, and if the value on the left is greater than the value on the right, swap them. So we'll swap 3 and 5, and 2 and 1 will be unchanged because we haven't looked at them. Okay, then we'll move on to the third and fourth value. 4 already done, then we are done with the 3, and then we have to do 2. All right, then we have 5 and 1 to be compared with, and we'll compare 1 and 5 together, and we'll obviously swap them as the left value is greater than the value on the right. 4 already done, 3 done, 2 done, then 1 and 5 are done, and we'll mark 5 with the green one here, because if we look, we have to go in the ascending order. Ascending order says as we are having 1 2 3 4 5, and 5 is the largest value, so largest value will be at the bottommost, and 5 is already at the bottommost position. Okay, so we can have an analysis of that. We started with the comparisons of two adjacent values, and after some repetitions, we have come up with one single value at its correct position. That value is 5. All right. I'll clean up some space so that we repeat the same process one more time. I can name it as the whole of the process. Okay. And we'll run a second pass. And for the second pass, we'll be using these values now. Starting with the values 4 and 3, we'll compare them, and as a rule said, if the left value is greater than the right value, swap them. Comparing these two now, 4 and 1, 4 and 5. No comparison is required between 4 and 5 because we know 4 is the second largest value, so it must be at the second bottom. All right. Well, for the second pass, we have come up with the two sorted values. We'll do another pass named as pass 3, and we'll use this status of the array for the next pass. Starting with 3 and 2, comparing them together, we'll have a swap. And then we'll compare 3 and 1 together, and we'll again have a swap. And 3 is again, we have a sorted value because we know it's a third sorted value. We can't have comparison between 3 and 4, so we'll stop here and we'll have as 4. And there is a reason we are not continuing right here and we are having a separate pass. I'll tell the reason later because we have to make an algorithm for it. We'll continue from this array, starting with 2 and 1 to be compared with. We'll do a comparison between 2 and 1, and yes, 2 on the left is greater than 1 on the right. We'll swap them, and there we can see we have sorted values of 1 and 2. We have a whole sorted array. All right, now comes the analysis part.